makes empty space, the void itself, curve. It seems a bizarre idea, but Einstein's incredible idea could be proved by looking at the stars. If light from a distant star passes close to the sun, according to Einstein, it will change direction, and the apparent position of stars beyond the sun will shift. We'd be able to see stars in positions that weren't there before. Normally, the sun is so bright that it blanks out the stars that are in the sky behind it. But there is a rare occasion when we can see the stars behind the sun, and that is during a total eclipse. During an eclipse, the sun's disk is completely darkened. The temperature drops and the sky becomes black, and some of the stars, which the sun's light usually hides, become visible. Now, if you take a photo of a star that can be seen just past the sun's edge, the light from that star will be passing extremely close to the sun. And if Einstein is right, then that light will have bent a tiny amount, and so the position of that star will appear to have shifted from where it normally is when the sun isn't in front of it. To prove his theory, Einstein encouraged, cajoled, and convinced astronomers to watch stars during a solar eclipse, because if the position of those stars had shifted even a tiny bit, then his theory would be proved right. In 1919, there was a total solar eclipse, and a team of the finest British astronomers, led by Arthur Eddington, armed with the best telescopes and photographic equipment, went to Africa and Brazil to prove whether Einstein's mad ideas about space and time were true. The scientific world held its breath and waited for the result. It took months to do all the comparisons and calculations, but in a meeting of the prestigious Royal Astronomical Society in London in November 1919, Eddington and his colleagues were able to stand up and say, "Our photographic data proves unambiguously that Einstein is right." Overnight, Einstein became a world celebrity. The new Newton, a global hero. There were cartoons of the whole Earth with a single flag attached to the planet saying simply, "Albert Einstein lived here." He became not just a celebrity, but a kind of role model of what it was to be a scientist, what it was to be a genius, the one person that had seen the secrets of the universe. Indeed, one person who visited Einstein said that visiting Einstein's like visiting the fourth dimension. He stopped being a human being. He became a force of nature. And the drama with which this revolutionary discovery was proclaimed put the new science of light right at the center of the news media. It made the physics of light into a global event. But above all, what Einstein had done was overturn 3,000 years of thinking about light. Every philosopher, from the ancient Greeks to 9th century Arabs, from medieval monks to Isaac Newton, from Galileo to Maxwell, had unquestioningly accepted one fact about light. It travels in straight lines. And now Einstein had shown that even this was wrong. So Einstein was right. light doesn't travel in perfectly straight lines, because as it passes through a space and a time which is curved, light departs from the straight and narrow. Light had once been the symbol of reliability. It had been the astronomers' most powerful tool, giving them the basic techniques needed to find out how the cosmos works. But Einstein's revelations had shown that far from being reliable, light was a puzzle, a problem. Light no longer traveled only in straight lines. It twisted, turned, and strayed. Einstein's world had become a place which could no longer be taken for granted, and the message that light brought from the most distant stars that we thought we'd understood had changed into a new puzzle, a puzzle to challenge the human intellect.